this question is a fundamental counting principle. We're going to talk about kind of the difference between that and permutation. So they've given us the word matching, and they've told us that the odd numbered letters in the word, so 1, 2, 3, 4, 5, 6, and 7, so 1, 3, 5, and 7, they have to stay stagnant. Like they can't change, they have to stay the way they are. So think of it like they're kind of like pillars here. Okay? So in other words, M doesn't change, T doesn't change, H doesn't change, and N doesn't change. So the only ones that will move are 2, 4, 6, and 8. So really now, the whole question is asking, how many different ways can we arrange A, C, I, and not N, but G? A, C, I, and G. So now it's down to 4, right? And did they say anything about repetition in the question at all?
No.
No? Okay. Assuming that we're not repeating the letters, that once you use a letter, it's taking up that spot, there's really only 4 spots now, right? We have 1, 2, 3, 4 spots. And if that's the case, if we're filling the 4 spots, so we'll call that spot 1, spot 2, 3, and 4. Once you use a letter, okay, you've used whatever letter, so let's say it's a letter G. You had 4 options there. But once you've used G, you now only have 3 options. And then once you've used, let's say it was the letter I, you've now used 2 of the letters, so there's only 2 letters left, and then there's only 1 letter left, right? So depending on which letter is first, as you choose a letter, your options constantly go down, down, down. So in other words, 4, 3, 2, 1 is really just the idea of 4 factorial. And 4 by 3 is 12, times 2 is 24, times 1 is still 24. So there are 24 options in this question. It changes it from being a permutation because the permutation would be asking you here, well actually, let's see if we can't. Permutation to solve it, it's the same idea. The question's asking how many different ways can you choose 4 letters out of a total of 4, the A, C, the I, and the G, right? So we use like a counting principle, but the same concept of 4P4 works fine because a permutation is calculated by n factorial over n minus r factorial. Okay, so your n is usually your first term and your r is your second term there. So if that's the case, you have 4 factorial over 4 subtract 4 factorial. 4 factorial divided by, do you know what 0 factorial is? 1. That's right. So you're looking at 4 factorial divided by 1. 1 is unimportant, so really it's 4 factorial, and we already solved that way up there. The idea is 24. So the hardest part of this question is essentially pulling out that information from that matching, right? Otherwise, you can use counting principle. You can set it up this way, or you can set it up as a permutation. Both ways will get you the right answer. You just got to realize that 4 of the letters are no longer letters we're going to use. They're not important to us because they can't change it.